Alright, last lesson had a lot of information in it. Today we're going to focus on adding, subtracting, multiplying, and dividing, and a little bit of domain work, so hopefully this goes pretty smoothly for you. First thing, we just need to talk about some notation. So whenever you see f plus g of x, okay, it's not multiplying by x, it's f plus g of x. That is exactly the same thing as taking function f of x and adding function g of x. Next one, when you see f minus g of x, again, you're not multiplying here, you are subtracting. It's the same thing as having f of x minus g of x. Now be careful here because order matters. Just like in subtraction, order matters. Next one, now we get to do a little bit of multiplying. F times g of x, you're going to take f of x and multiply it with g of x. Last one, we've got f divided by g of x. So that's the same thing as taking f of x and dividing it by g of x. Again, in this one, order matters. Alright, notice you're not multiplying by x ever in these. Okay, you're just applying two functions and you are adding, subtracting, multiplying, or dividing. So we're going to use f of x and g of x in all of these examples, and our goal is to find our new function h of x and also state its domain. So we're not worried about range, just domain. H of x is f of x minus g of x. Well, that means I'm going to take f of x and I'm going to subtract g of x. Now, it's important that you put g of x in parentheses because you want this negative sign to distribute to both. So that is going to give us 3x squared plus 6x minus 4 minus x squared plus 8. Doing a little simplifying. There's your final answer. The domain of our squaring function is going to be all reals. Next one, we are going to take g of x and we are going to add to it f of x, giving us our new function 4x squared plus 6x minus 12. Again, this is just a good old squaring function, so our domain is going to be all reals. Next, we're going to take 2 times g of x we are going to subtract off 3 times f of x. I'm going to have some distributing happening here. Combine your like terms, 2x squared minus 9x squared. Hopefully when you're taking notes you are doing this just as quickly as I am able to. And you should just be checking your answers as mine are going along. Still, we just have a quadratic. So our domain is negative infinity to infinity. If you think about it, your quadratic, you're squaring numbers. You can square any number you want to. Our range on these would definitely be changing, but we're not going to deal with range today. Alright, this time we're switching our f of x and g of x just a little bit, but we are still finding h of x. So here we're going to take f of x, which in this case is 3x minus 4, and we are going to multiply it with 2x plus 1. So doing some foiling. Outside, inside, last. It's going to give us 6x squared minus 5x minus 4. Just a quadratic. Our domain is going to be all real numbers. Last one, f of x divided by g of x. We're going to have 3x minus 4 divided by 2x plus 1. Now, in this case, we are not ending up with a quadratic. We've got to think about our dividing function, that reciprocal parent function, what our restrictions are. Well, when you're dividing, what's the one thing you cannot divide by? Hopefully all of you just said 0 at your computer screen. So that means that our denominator, 2x plus 1, cannot be 0. Well, what would make that 0? Means we need to subtract 1, divide by 2, so x can't be equal to negative a half. So our domain would be negative infinity to negative a half, skip over negative a half, pick back up on the other side of it, and keep going to infinity. Okay? Just a quick little side note, keep in mind this could have been written as f times g of x, and it would mean the same thing. This could have been written as f divided by g, and it would have meant the same thing. Alright, let's keep it going. We want f divided by g of x. So remember, that's the same thing as saying f of x divided by g of x. We've changed our functions just a little bit. Get some new numbers in there. Dividing by x plus 4. Well, this time we end up again with that reciprocal function, that dividing. And what are we not allowed to divide by? 0. So that means our denominator cannot be 0, which means x itself cannot be negative 4. So our domain is going to be all real, skipping over negative 4. Alright, I want you to try the next one, g divided by f of x. Go ahead and find the new function, and I want you to state its domain. Pause the video and do that. Alright, my favorite part of movie making, the fact that I can write things down while you guys have your videos paused. G of x divided by f of x results in x squared minus 5 on the bottom. Well, that cannot be equal to 0, which means that x itself cannot be plus or minus the square root of 5, which means you're going to go negative infinity to negative root 5, skip negative root 5 and pick up on the other side. Keep going to square root of 5, skip square root of 5, and then on to infinity. Alright, this last example you don't have in your notes, but I want you to see it because I want you to get the picture in your head for what we're talking about here. So I've got two different functions, blue and red, g of x and f of x, and I'm starting by saying f minus g of 3. Well, if you think about f minus g of x, that meant f of x minus g of x. This time, though, we have a 3 instead of x. So I'm going to say that what I really want is f of 3 minus g of 3. So let's go to 3, 1, 2, 3, and find f of 3, which is 2. And then we're going to subtract off g of 3. So let's go to 3. Our g value is 0, which means f minus g of 3 is equal to 2. The other way to look at that is taking your f of x value and subtracting off your g of x value. This is 2. Where is f minus g positive, negative, 0? Well, f minus g, again, means f of x minus g of x. Our whole graph lies above the x-axis, so we're talking about all positive values for f of x, g of x, maybe a 0 in there, which means that our graph, f minus g of x is going to be positive whenever f of x is bigger than g of x. Well, where is that happening? Where is f of x, that y value, higher than g? Looks like we're going negative 1 until 0. And then we switch, it's below the blue, and then we're back above between 2 and 5. That one should be a parenthesis. Where is f minus g negative? Well, that's going to mean that your f of x is smaller than g of x. So here, the red function f of x is smaller than g of x, so that looks like we're going 0 to 2. Together with 5, and we'll say it's going to 6. I don't really know where this graph ends, but we're going to say it looks like 6 is that last dot. So then the last one says, well, where is f minus g equal to 0? Well, if you're going to subtract something from another, and it's going to be 0, that means that f of x must be equal to g of x. And we know from solving systems of equations, graphs are equal where they are crossing each other. So it looks like we're at 0, 2, and 5. Thinking about our domain, we're going -1 to 0, then we fill in 0, 0 to 2, fill in 2, 2 to 5, fill in 5, then to 6, because this is a continuous function. Alright, adding, subtracting, multiplying, dividing. It's up to you now.